Hmm. Good afternoon to all of you, those who are attending this live session of the MOOCs course on membrane technology. So welcome all of you. So as you know that we have almost in the middle, we have passed the middle actually 50% of the course. So we have covered actually our details like which included the basics of membrane technology, membrane processes, membrane separation processes. Let us say like that. Then we have also discussed about how to prepare or manufacture the synthetic membrane. We have discussed about the materials, their typical properties. Mostly, you see that we have discussed polymeric materials, different polymeric materials like polyethylene, polystyrene, PTFE, and PVDF, nylon. Then one another interesting class of the membrane, which are called ceramic membranes, and we have also learned about the physical or physicochemical properties of the different materials that are being used to prepare ceramic membrane. Then after learning these properties of the membrane materials, we have studied how to prepare membranes by various methods, right? I'm sure you must have gone through all these details. So where we have discussed the sintering method, deep coating method, and there are various. I'm not going to tell the names of everything, right? So typically we have seen and we have covered various processes to prepare our membranes, polymeric membranes, then ceramic membranes, and also ceramic based composite membranes. So one ceramic membrane you prepare, use it as a base material, then how do you graft it over some polymers and all such other materials to increase the to decrease the pore size, right? Usually what happens when you prepare a ceramic membrane, it usually comes in the microfiltration range, right? So if we are happy with that range, for some applications it is fine, perfectly fine, or else we go on decreasing the pore size of that ceramic membrane by different methods. You can have finer materials, You can have our polymeric materials that is being grafted on the top of the ceramic support to make it a composite membrane. So the base will be ceramic membrane, the top will be polymeric membranes. So here we have seen in our own research lab also, we have seen that we have gone up to ultrafiltration range, which itself is a very nice thing, right? So after we discussed about how to prepare membranes, the next thing is that once you prepare membrane, how do you characterize it? So this characterization of membrane is one of the most important thing that all the membrane researchers must learn. Okay. So characterizing the ultrafiltration membranes, characterizing the microfiltration membrane, and other various membranes. Okay, so we started with the initial characterization techniques like microfiltration, SEM and TEM. Okay, scanning electron microscopy, transmission electron microscopy. Okay, these are some of the methods. High resolution micrographic pictures we obtain. Then you do image analysis and go for our finding out the pore size and all these things. Then there are other techniques like the usual bubble point method, the modified bubble point method, then mercury infusion method, and every such method has certain pros and certain cons. Like if you see the same and ten, so basically you are characterizing from the top, right? So when you characterize from the top, you are not at all discussing or you are not at all actually getting information about what is happening at the bottom. So it may happen that many times I have told you during the class, no, that it may happen that the bottom of the membrane pores are sealed. That means they are dead end pores. So when we are not supposed to actually include them when we talk about membrane characterization. But if you go for surface analysis like SEM and TEM, it ultimately gets analyzed. So it gives you little exaggerated value of what you are looking for. Doesn't matter, but it is both SEM and TEM are very essential techniques to or analytical tools to characterize the membrane. Then when you talk about our this one, what is that is called other methods, no, like the bubble point method and all. So this is a good method here. Either the usual bubble point method where you blow nitrogen from the bottom, in which your membrane is being hot, and over that you pour some liquid, which is not supposed to wet the membrane, right? Now, what happens? This gives us better reading because this is only characterizing the open pores. That means you are passing nitrogen from the bottom, na? So that is the reason why That is the reason we are characterizing only the through pores or the pores which are open to both sides or which are going to be used in the separation process, right? So then there is modified bubble point method, and another interesting and important analytical tool to characterize membrane is of course mercury intrusion method. Now mercury intrusion is a very age-old technique to characterize pores in catalysts, adsorbents. Okay, solid catalyst and solid adsorbents. But the only problem again is that here the mercury is getting inside the pores and it comes out. So again, it also takes into account the dead end, right? Otherwise, it is a very accurate technique because you know the particular amount of mercury that is getting inside the pores getting filled. Okay, mercury will not wet the membrane pores, right? And then you have also you can also find out the pore volume, which you do not find out from usually other analytical techniques. There are other ways also there, but this is a proven. This is the most important analytical tool to find out the pore size as well as pore volume. Okay, pore volume plays a significant role during our this one when you talk about membranes use in catalyst like catalytic for reaction purposes, catalytic membrane and such thing. Now then slowly we move to learn different membrane processes. We started with osmosis, then we discussed about reverse osmosis. Now we are discussing, okay, other things are also going on. Slowly we'll also learn about other processes like ultrafiltration, microfiltration, dialysis, electrodialysis, then piezo-dialysis. Okay, all such processes we'll be covering, and we'll also talk about nanofiltration. Then another important thing which we discussed in between is our thermodynamic considerations. Okay, how do we calculate various parameters, and we also discussed about the models like osmotic pressure model and all such models which are essential for separation processes, right? So I think we are not, we have not covered much than what I'm just telling you right now. So if you have any specific queries, you please type it so that I can address it, or you can type in the live box in the YouTube chat box here also, that is also fine, so that I can answer you. In the then again, actually we'll be going ahead and discussing about the processes in detail. Okay, then we'll also discuss about something very interesting which is called hybrid membrane processes. How a particular membrane process can be clubbed together with the other unit operations, like let us say distillation clubbed with pervaporation. Okay, I forgot about pervaporation. It is a very important membrane process which we are going to discuss, okay, in the subsequent classes, right? And then certain other things that will be taught with little applications. How do we use membrane in different process industries, right? One classic example is the dairy, you know, dairy industry is one of the interesting industry where membrane is being used in various processes, because there are various processes that is going on. One is this milk enrichment, of course, right? You know about these things. Then cheese making, curd making. Then there are so many other things, right? So every process is, or rather say, uses some sort of membranes. Where it is microfiltration, somewhere it is ultrafiltration, somewhere it can be your NF or RO, such membranes. Okay, right. So if you have any specific questions, please go ahead and ask me. I'll be happy to answer. In our next live session, we'll discuss about the final exam. Okay. Yeah, someone is asking about, just a minute. Let me see the question here again. Oh, it's not here. Okay, fine. So, someone is asking about regarding the permeability of membrane. Where is the unit used? GPU for permeance for better understanding which is useful. Now you can use both. There is no hard and fast rule actually to which to be used. Where is a very accepted unit also, and so you can use that also. Any other question? Bearer is a non-SI unit actually, and your this one GPU is also nothing but bearer expressed in membrane thickness. Okay, the thickness can be in microns. Okay, one more question I received. For polymers with intrinsic microporosity, most of the journal paper thickness is not specified. Then how can we compare or select a particular membrane? I could not understand. If you are talking about comparison of your own data with the literature, then it is a very different thing if the data is not provided in the literature. Okay. Otherwise, in means what is your intention? If you can write properly, I can better answer these questions. If the data is not given, then nothing can be done. So there are various ways to calculate thickness. We have already discussed, no? Like membrane thickness and all. Okay, another question. How recycled configuration is increasing the cross flow velocity? Okay, that's because, see, so I don't have anything to draw here. See, you have a membrane module. Your feed is entering here. Let us say entering here. Okay, your permeate is coming here, and your retentate is going up. That's the three streams. Okay. Now, when you do recycle, what you do basically is that part of the retentate you recycle back to the feed permeate. Okay. So basically, you are increasing the amount of feed. Now velocity depends on what amount you are drawing the recycled part, as well as at what velocity you are feeding your this one, the entire feed. So that part it's getting drawn. No, suppose that the retentate is one line, you are taking one part of that. Okay. So it is just like a reflux in the distillation column. If chemical engineers are there, they can understand. Okay. So part of the retentate is getting back to the feed. Okay, and it is getting drawn. So that drawn, that velocity, that at what velocity you are drawing will be your recycle velocity, and you can control it. Okay, but the only thing is that these are all optimized parameters. Nothing can be said that what 1 ml per minute, 5 ml per minute, 100 ml per minute, 1 liter per minute. What should be, that depends upon your size and configuration. Okay, so how much you will actually want to recycle back to increase. So there is a need to do it. It is done the cross the recycle. No, it is done to enrich something. Basically, if you remember, we discussed about our proteins and antibodies purification. So what happen when we purify antibodies or certain proteins? Antibody is itself a protein only. Their initial purity in the culture broth in which they are actually getting produced is around 6 to 7%, maybe little more, 8%, never more than that. So that is why you recycle. When you retent it na, in the first time, you may get 10 to 12 or 13. Okay, then you actually recycle. So your initial part of that na, so or you can go for a total recycle also. Okay, so that your feed gets continuously enriched. So finally you may draw without recycling something which you are looking. Okay. Uh, if we are using submerged flat sheet membrane for lab scale wastewater treatment, means that would come under whether cross flow or dead end. I could not get the question. Submerged flat sheet membrane, okay, would comes under cross flow or dead end. Okay, 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 okay. Fine, fine. So actually, this will be partly cross flow type. There is no question of dead end here. Okay, dead end is also possible. It is not that we cannot have it. Actually, the it depends upon the configuration. Okay, So what type of flat sheet membrane you are using? Okay, so that is very important. So depending upon that, actually you can decide, and there is no hard and fast rule actually. Okay. Now you know that in submerged system, na, your entire membrane is being hanged like this. Let us say this is a reactor or a wastewater treatment tank. Okay, so on inside which the membranes are hanged literally. Okay, so if you recall the electrodialysis setup unit, it's something like that, right? So they are flat sheet membrane. Flat sheet membrane works in a very different way. Okay. Yeah, actually, if I come back to your question, so these plastic membranes are good, has been used in commercially also, but the problem is nothing but the fouling, or which comes as a result of the what is that is called concentration polarization. Okay, so there are various mechanisms, like if you can go by this um, we discussed like increasing the air flow rate, and how to we can have baffles also. Okay, so there are ways to do that. Okay, Srinath is saying something. My aim is to select a membrane having high permeability and selectivity from literature. Various literature provide data permeability in bearer and with different thickness. How can we compare? No, no, no. See, yeah, actually, what is your intent? What you want to do? So, you want to, what type of application you are looking for, and what is your intention? What you want to do? Purification, wastewater treatment. So you go look for pervaporation or some enrichment, concentration. You know, various things. So anyway, whatever it is, this one, it is very difficult to take or choose membrane depending upon the literature data. Of course, you can get some information, but when you do research in the lab scale, we always have our own membrane. Either you take commercial membranes, then modify them, or use it as it is, or we prepare our own membranes. Then we go for different process optimization. So it is not so easy that somebody has done something and you can directly use it. So you have to do experiments to fine tune your own need and to arrive at a particular membrane selection. Uh, okay, so someone is asking, could you explain the selectivity of ionic membrane based on Donan equilibrium? Okay, so Donan equilibrium is nothing but the Gibbs Donan equilibrium, right? So that exists between two solutions that are separated by a membrane, two different solutions. Okay, so membrane is inserted, or let us say constructed or designed, let us say designed in such a way that it allows passage of only certain ions, that means the charged components of the solutions. Okay, now there are if you talk about if you remember the class note, and I am also correctly remembering, we discussed about the Donan effect uh, with the help of sodium and potassium ions. Okay, so there are what you can call it, there is a huge relationship between this Donan equilibrium with that of pH. Okay, because you change the pH, the equilibrium will change. Okay, or vice versa, both side. Okay. Okay. One more question. Since there are a lot of models available for fouling prediction and factors influencing the fouling, why we go for thermodynamic models? Because thermodynamic models are more accurate. They are based on the thermodynamic concept. Okay. Anything that is based on the first principles will obviously will give you better result now. So that is why these models are widely accepted. It is little difficult to use them at certain points. Nevertheless, they are more accurate. Okay, whatever various models are predicted for fouling purposes. Even we have also done something here. You know, at IIT Guwahati there is a big group of researchers who are working on membrane, the professors and their group. So you will see so many such model prediction and all, but please remember that any model has certain limit. Okay, that you cannot use beyond this limit, that limit. So every model suffers from certain things, certain limitations. So these are not no model is generalized. So you cannot use this particular fouling membrane which was developed for dairy wastewater treatment for another wastewater treatment which contains oils. Okay, or similar things. So that is not possible, na? So you have so for generalization you have always you need to go for first principles, including the thermodynamic concepts. Okay. Okay, so thank you all the participants who were actually joined today for this live session. And in our next live session, I'll be discussing about how exam will be conducted. Those who are interested to write the exam, the pattern of questions. Okay, so please be there to listen to from me in our next live session. And also, even whenever you are asking questions, now be specific, because due to the short time duration, it is difficult and to answer certain things. And don't ask research related things, because please understand that this is a course where we have learned basics. Okay, if you are interested to know something more about research of your own research, please write a mail to me. I'm sure and I can guarantee you that I'll reply you. Maybe one or two, that doesn't matter, but I always reply to mails. So I'll be happy to answer your research related queries. But in the course, let us stick to our course syllabus and all these things. So thank you very much for joining. I am now signing off. Okay, so see you in the next live session. Bye bye. Take care.